Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this utilization through topic wise MCQs, we have completed 4 sessions. I think it is the 5th one. Okay, let us start the session, guys. And students, if you want download the PDF, you can download from sunilengineeringacademy.com. Coming to the first question, the power factor will be maximum in case of dash. When we will get the maximum power factor? Whenever voltage and current are in phase. This will be happen in case of pure resistance case. Okay, so in case of resistance heating, there is a chance of maximum power factor. Which of the following methods of heating is independent of supply frequency? Independent of supply frequency. Okay, so in case of supply frequency, that will be induction heating, it is dependent on frequency. Dielectric heating, directly proportional to frequency. Okay, so here in case of electric resistance heating, there is independent of supply frequency na, so the answer is option C. Okay, electric heating is also correct. In the electric heating we have different types, so here particularly mentioned resistance heating na, so we need to go with the option C. The furnaces used for cremation are dash. The furnaces used for cremation are dash. That is nothing but generally we go with the electric resistance heating. Electric resistance heating. Very repeated question, guys. Very repeated question, this one. Answer is option A. The power factor will be leading in case of which heating? Will be leading in case of which heating? So the power factor may be leading in case of dielectric heating na. In case of dielectric heating only, there is a chance of leading power factor. Why? Because the current leads voltage. Current leads the voltage. So the answer is option A. The method of heating used for non-conducting materials. Non-conducting. If it is a non-conducting means it is a dielectric. So we can go with the dielectric heating. Correct. Non-conducting in the sense dielectric. So we can go with the dielectric heating. The method appropriate for the heating of non-ferrous metals. Non-ferrous metals. Very important. For non-ferrous, we go with indirect arc. Not direct arc, indirect arc heating. So the answer is option C. Okay, coming to the next question. During the resistance welding, the heat produced at the joint is proportional to dash. Joint proportional to dash. So the heat is nothing but energy, that is power into time, that is power is equal to I square R into time. So it is heat is proportional to the power, that is nothing but I square R. So the answer is option C. So the answer is option C. Okay. The metal surfaces for the electric resistance welding must be dash. A very important thing. The metal surfaces for electrical resistance welding must be cleaned. Then only the joint will be done. The welding will be done perfectly. Okay. So this is the first and most important point. The resistance welding cannot be used for dash. Resistance welding cannot be used for dielectrics. For dielectrics, there is no allow of current. So the resistance welding cannot be used for this. Okay. In the electrical resistance welding, the greatest resistance is offered by dash. The greatest resistance. Wherever there is a greatest resistance, in at that place we may get more power consumed. As more power consumed, more heat is produced. Then there is a chance of melting. Then there is a chance of welding completed. Okay. So that means the contact layer of the materials to or metals to be welded. Okay, so wherever there is a contact of layers of metals to be welded, at that place we have the greatest resistance, then they will be melted easily and becomes a single part. Okay. In the electric resistance welding, current required will be high. Yes, correct. Voltage somewhat of less, correct. Okay, so the amount of power supplied will be ranges from 60 to 80 watts for each square mm of area. It is also correct. So we can say answer is option D, all of the above. Okay. Plain and butt welds may be used on the materials up to thickness of about dash. So this plain and butt welds may be used on the materials up to thickness of 25 mm only, up to 25 mm. The spot welding process basically depends on. So welding process depends on heat and also forging pressure. Okay, so that is both. So the answer is option C, both A and B. The tips of electrodes for the spot welding are made up of dash. These are maybe copper alloy or pure copper. Okay, then only they take a lot of current through it. Okay, so copper alloy or pure copper. So this is the spot type of the welding. Spot welding. So if you observe carefully here, so here we can add the metal sheets here. Metal sheets here, but here we may not get the waterproof joint. If you want to get the waterproof joint, we require some pressure. In that case, we go with the seam. Okay, can go with the seam type of welding. Okay, here one more important point in the welding, which type of transformer we are using? Step down transformer. That is very important. In case of step down, voltage is reduced, current will be increased. Current will be increased. Okay. So here the tips of these electrodes are generally made with the copper. The power factor of spot welding machine is expected to be about. So here we can observe this in case of spot welding, the power factor will be very less. That is approximately 0.3 to 0.5. 0.3 to 0.5. Why? Because the current is high, voltage is low, then automatically there is a angle between the voltage and current, so we can get less power factor. During the spot welding, the current flows for dash. Here we need to flow of the current very fraction of seconds. Very fraction of seconds. Within the fraction of seconds, there is a high current is flowing now, then that will be melted. Okay, melted and that will be welded. The spot welding is employed for dash. So just now I have given the spot welding is employed for metal sheath. Okay, metal sheets. So thin metal sheets. Thin metal sheets. Maybe up to 25 mm. Generally, you can go with 10 to 12 mm. The spot welding is dash. It provides mechanical strength only. Spot welding provides mechanical strength. It may not provide airtight or watertight. If you want airtight and watertight, you can go with the steam type welding. Okay, in that we have two rollers are there. They will apply a lot of pressure. Due to that pressure, the tight will be very airtight and watertight. Okay. The projection welding can be considered as mass production of dash. It is nothing but a spot welding, but wherever we require mass production, we can go with the projection type welding. Okay, and also due to this projection type welding, we can weld with not similar items. Okay, the shapes are not similar, then also you can weld. Okay, so this is the projection type welding. So here, if we have different shapes, also we can going to be weld. Okay, so here also welding transformer is a step down transformer. Step down transformer. The basic electrical requirement in the arc welding is that there should be dash. There should be dash. There should be must be high open circuit voltage. Okay, whenever there is a high open circuit voltage, then only there is a chance of producing arc. Okay, so high open circuit voltage. In the arc welding, the temperature of the arc produced is of the order of dash. This temperature of the arc must be in the limit of 3000 to 4000, so 3500 to 4000 degrees centigrade. Okay, the electric arc has dash. The electric arc always negative resistance characteristics. Why? Because as voltage decreases, current increases. So inversely. So that means you can say negative resistance characteristics. Okay. the arc can be produced by dash. The arc can be produced by dash. AC current, DC current, either AC or DC, all of them, either AC or DC. Okay, either AC or DC. Coming to the next question. The resistance of arc is dash. The resistance of arc is dash. Decrease with increase in the current. Increase with increase of the current. Does not depend upon the current, and none of the above. None of the above. So the resistance of the arc decrease with the increase of the current. Here what is the answer? The resistance of the arc is decrease with increase of the current. Whenever the current is increases, that resistance is going to be, it decreases. Okay, so the answer is option A. Answer is option A. Coming to the next question. In an electric welding, the voltage required to strike DC arc is about. For DC, it is less voltage is required. So just 50 to 60 volt. If it is a AC, then it will be 80 to 90 volts. Yes, here they have given. In case of AC, we require 80 to 90 volts. Okay. For an electric arc welding, the current range is usually dash. The current range is very high, usually 50 to 1000 amps also. 50 to 1000 amps also. During the electric arc welding, as the thickness of metal to be welded increases dash. Increases dash. So as thickness is increases, that means you can say the resistance is going to be less, then the current should be very high. So the current is increased, keeping voltage as unchanged. Keeping as unchanged. Okay, as thickness is more, that is area is more, resistance is less, then you can get more current flowing through that one. So the answer is option B. The length of arc required depends on dash. It depends on electrodes and diameter of the electrode, magnitude of current, and position of welding. So you can say all of the above. So the answer is option D. It is a very repeated question. A 10 SWG electrode has the approximate diameter of, that is nothing but 3.3 meter. Approximate diameter of 3.3 meter. Which of the following falls under the category of fusion or non-pressure welding? In case of fusion or non-pressure welding, we go with metal arc welding. Okay, we go with the metal arc welding. So in the argon arc welding, the electrodes are generally made up of tungsten. So the answer is option C. The MIG welding, metal inert gas welding, is become more and more popular as it dash because of its easy operation, and also it has high metal deposit rate. So the both options are correct. So the answer is option C, both A and B. In ultrasonic welding, ultrasonic means greater than 20 kilohertz. The frequency range is should be dash. So greater than 20 kilohertz means 20 to 60 kilohertz. Okay. The AC welding machine cannot be used for dash. This AC welding machine cannot be used for MIG welding. Here we go with the DC type. The transformer used in a welding set. The transformer used in a welding set. I have given so many times. Step down transformer. Step down transformer. A rectifier used for welding has voltage current characteristics. Voltage current characteristics are always drooping characteristics. Why? Because as the current increases, voltage is going to be decreases. Okay, voltage is going to be decreases. So the answer is option A, drooping characteristics. Okay. Okay, students, we will discuss the remaining questions in the next session. And students, if you want to download the PDF, you can download from sunelengineeringacademy.com. Okay, in the PDF of this utilization through topic wise MCQs, I have given lot of data about all the weldings. Okay, spot welding, seam welding, projection welding, all the weldings. Okay, so try to download the PDF and read that PDF also. Okay. And students, if you like my classes, don't forget click on like button and also please share to all your friends. In our classes, I have not given any unnecessary data. Okay, that is, I am not talking anything about the parts about any other points. Okay, so only exam basis. Okay, students, thank you so much for watching.